Okay, welcome to the Think to Think Research Group work meeting. Today we are going to have a 1-hour meeting, so I'm going to go through the preliminaries quickly, so we can go into the content of the meeting. Ari is still stuck in a family event and probably will join us in a few minutes if you wonder where he is. So this is an IRTF meeting. So the IRTF note well applies, and the short form of it is you may be recorded, or you will be recorded actually. We are all trying to be nice to each other and professional, whatever that word means. And there are IPR guidelines, really, which are about patent claims, and you can read them on the website pointed to here. And there are also official slides that point to more detailed ways of doing things. So how you actually reach someone to help you if the chairs are not helping you and you believe to be harassed and so on. The IPR rules are mainly meant to avoid submarine patents influencing the standardization process, but they do apply to the IRTF as well, and you should know about these things, and in particular, if you know about a patent that applies to some technology, you should tell us about it, or you must not talk about it. Okay, so that's my summary. I'm not a lawyer. Please read the actual documents. So just a quick reminder, this is not a standards development meeting. This is a research group meeting. The point of the research group is to have a longer term view on the issues, which in the end, of course, do impact on standardization, but we're not doing standards here. And there are a number of media that are helping us doing this thing. In particular, there is a note-taking site where we can do shared note-taking. And I see that Marco has already started doing that, and it would be good if he got some additional support from people who are interested in the subjects. The Jabber is gone. We now are using Zulip, but you also can get at the chat from the Meet Echo buttons. We have a mailing list. If you are not subscribed to, please do so. And documents about this will, apart from the normal IETF proceedings mechanism, be collected in a GitHub repository. So I'm not going to do these slides here in detail. They are just in the slide deck for reference. You can get at the slide deck at the link where that I sent around an hour ago on the mailing list. And the same is true about the interesting relationship that this research group has with various IETF groups that are kind of both the parents and the children of activities that have happened in the research group are simply related to it. Okay, so today's meeting is a short 1-hour work meeting, and we want to focus on the subject of security. We have 3 active research group drafts on security issues, which we are discussing today. And we also have 1 potential field of new work where I want to gauge what the level of interest in this group is, whether people would be interested in contributing to some additional work. So the resulting agenda has John starting in -13 seconds on amplification attacks, Mohit and Dan about the terminology and processes for initial security setup, and Michael on the taxonomy for keys, for manufacturer installed keys and trust anchors. We don't really have the time to do all 4 items in 15 minutes, so we will compress the discovery discussion at the end if we need more time. So Michael, you don't have to feel like you must stay within 5 minutes, but of course I would appreciate if you don't need 25. Any comments on the agenda? Anything we should also cover today? I'm not hearing anything. I think I'll share John's slides.
Thank you.
And you should now also have slides control.
Yeah, I do. So this is about the amplification attack drafts. I think it has been updated 3 versions since it was presented in Thing2TRG last. It has also been adopted by the working group, research group since then. But most of the changes are based on comments from Achim Kraus and discussing with Sultan. One thing that has been done is that added a gateway and text about gateways for all the multicast figures. Gateways are discussed a lot in group communication, and they explain why you can do amplification attacks over multicast. Then observe was made a separate figure based on a comment from Achim. Added text as the draft does not suggest that co-op is more vulnerable to amplification attacks than other protocols. Maybe it is, maybe it isn't, but we don't state that. Some readers got that impression before, even if that was not stated. Added that post and put is only possible if supported, and same with conditional attributes. Typically, these things are maybe not supported. Remove the whole section about actual amplification attacks. There was a lot of discussion. Seems like there happened actual amplification attacks using co-op, but all the description of these attacks are so bad, so you cannot really draw any conclusion what actually happened, or maybe even if it happened. Then a lot of clarification in the figures with client was changed to victim and server to servers, and we made SVG out of everything. Here's an example of the new figures where it used to be client, it used to be single server, it used to be no gateway. And after discussion with Sultan that didn't understand the attacks, I think this is now, and Achim complaining that this attack was not realistic. I think the name changes here and the addition of the gateway makes everything much clearer how the attack is actually done. I think there's basically no changes to the text. I think it's time to discuss I think the draft is in a quite good state right now. We got quite a lot of detailed comments by people that actually had read the draft in detail, and we have addressed them. There's 2 remaining comments from Achim about man in the middle attack. I think they're quite straightforward to fix. But then I think the big question is, what does the working group want this draft to include before it's published? I hope we will publish it at some point. I think these are the 4 points that was discussed in an earlier session in Thing2TRG. I think the draft does already now raise awareness. It has some mitigation, but Achim commented that the mitigation sections are quite slim. I agree. There should be more mitigation sections to a reasonable level. We have removed concrete information, and I don't there's not been any interest to add any other types of denial of service attacks. So my suggestion is that we are done with describing different attacks. Now we should add recommended and suggested mitigations for the already described attacks. And after that, my view would be that the draft is ready for publishing. Comments, Karsten?
Yeah, I have a quick question. When you say describe mitigations, of course, there are documents out there that already do that. So is that really about describing them or pointing to the right documents? What is the relative weight of these two aspects?
Yeah, I think that maybe needs some analyze and trying to write. I guess first point is to point to existing, and then maybe in some cases these mitigations are too soft, so maybe the draft should recommend to have a bit stricter things, or maybe in some cases there are no descriptions, and then the draft might have to describe new things. But I think when I started this draft, there was not so much written about multicast. Now the new drafts have added a lot more. I think there's still no recommendations in, for example, conditional attributes. So I think referring to all the current and then see if that is enough and where there's new things, more things that can be done. But
Yeah,
I think that's the activity. Yeah.
I'm asking because there is a danger that we are writing a BCP here, and that is not the intention of a research group document. So we should document the state of the art, and of course the state of the art includes specifications that are already out there, and considerations for potential future specifications. But I don't think we should be recommending stricter limits for something. We might very well note that stricter limits might help more, but I think if there is work that needs to be done in the IETF, we should identify that and see to it that this work is actually started.
Yeah. There will not be any. The plan is not to have any RFC 2116 language in this draft. And then I think let's identify all the different sorts of mitigation first, and then we can discuss how we want to describe that. I think, but in general, I agree with you here. Michael?
Yeah, so I think the document is, I guess I thought it seemed shorter than I thought it might be, but one question is whether or not you basically concluded there are no amplification attacks involving the various block mode transfers, or is that at this point?
No, I don't know if that has been considered. I think everything we have, it's more like you find some attack vector and then you add it to the document, but I cannot be sure that we have found everything. If you, I can.
I don't know. I
can't
think of any, because both participants have to be involved in doing the bigger transfer. So I think it's not the case, but I guess that would be good to know. And I guess the other concern I have is I guess I wouldn't mind if the terminology, the names of them were a little bit more unique, as opposed to application using something. So I don't know. That's just useful. I think that's the utility of having this is that we now have a common understanding of the different kinds of attacks, and we can talk about when someone's using COAP, they can talk about, oh, and this isn't a problem, this kind of attack isn't a problem, or whatever.
I'm open for suggestions. If you have some good name suggestion, feel free to contribute.
Okay.
And here are so initial high-level suggestion is to have some general mitigations assumption. Then you might need to separate the mitigations in whether when you use a security protocol and when you're not using security protocol, and when you have verified the address of the destination, and when you have not. And then here is just very high level some of the mitigations that have been discussed in this draft and in other drafts. And I think the plan is to add some more information about this mitigation, maybe some analysis how effective or not effective they are, and if there's any loopholes. Mohit?
Can you hear me?
Yes.
Okay. I find this document useful. I also found this document that you have in the core working group. This actuator attacks that you have. Maybe I had been using that document quite a lot for describing some of these attacks against actuators. I wonder, is there like some consideration about this resource directory where like the responses might be much larger? Let's say if you do some RD lookup or observe things in RDs, there are some special considerations that apply to those kind of scenarios that is worth covering in this amplification attacks document.
I don't know, but I think that might be good to investigate. Would it be possible for you, Mohit, to open an issue and describe a little bit high level what you're thinking is, why this might be a problem, and then I can help analyze and see if we can find something specific for that scenario that should be described.
Yeah, sounds good.
Good. We have two new things that should be investigated, whether they should be described attacks, and I think seems to be rough consensus on the way forward.
Good. So we have several items that we can pick up after this meeting. I talk about discovery a little bit at the end, and Mohit's comment is definitely of interest in that context as well. So I think we are done with this item. Thanks, John. And we can move to initial security setup. Mohit, I think you are presenting this, so I'll pass you the control. So you should have control now.
Yes, I do have. So yeah, good to join some of you virtually after let's say short gap. So this is work done together with Pechet and Dan, who is also on the call. This draft has existed for a while, and there's been let's say some lack of also action from the authors for various reasons. They have been busy, but at least now some of us have time to hopefully finish off the draft. So quickly to kind of summarize what has changed since the last time this was presented in T2TRG by Dan. Actually nothing much except maybe the title of the document itself. So at some point we changed the, let's say, title from Secure Bootstrapping Survey to a survey of initial security setup techniques for IoT devices, but we never really changed the document name to match the title. And I guess that was raised as feedback during the last presentation. So now that is done. Also, we received some off-list feedback from Jaime on specifically about OMA. We haven't addressed this, but we do plan to address it in the next version when we submit the draft. So in case there's someone who doesn't know what this draft is about, very quick recap. So basically this draft is trying to capture different terminologies that are used in protocols for doing this initial security setup of IoT devices, and then see if there are some common patterns in terms of the terminology used, what are the processes, and what are the initial assumptions before you can do this initial security setup, and what happens after the process is complete. We use some illustrative examples of both IETF and non-IETF protocols in the draft. So this is basically the list of terminology that we found in different protocols that have been standardized for doing the initial security setup of devices. And when we try to break this down, we try to break this down so that each protocol we can list the players, the beliefs before the protocol, and what happens once the protocol run is complete, and also identify the processes for each of these standard protocols. I'll have example of OMA at the end and have some questions for you in the audience on how exactly to structure this, because it's actually a little bit challenging when reading the different protocols, what exactly are the players and processes. But the protocols that we have reviewed so far are listed on this slide. I don't think we have received any requests for adding new ones or removing ones from this list. But if you have feedback on that, that's always welcome. If you think we can remove some of them because they are not maybe relevant, that's all right. If you think we should add, obviously we can add some other protocols which we might have missed, but as mentioned, this is not supposed to be an exhaustive list. It's more supposed to be diverse enough to cover as many different types of protocols, or at least a representative of different types of protocols, but not be an exhaustive list. So if you have any feedback on whether there should be some added or some removed, then that's always welcome. Yeah, I think we already mentioned that we try to then compare protocols based on what terminology, players, processes they have. And I guess the document is not complete. We obviously have lots to improve. We also look forward to your reviews and feedback. But let's say we would like the next version of the document to be a little bit major revision to at least to get in the direction where we feel it's starting to look finalized. It's not there yet. But before we do this major revision, I thought it was good to take some feedback from the research group on what exactly is useful, and we would like to make the current document much better than it is currently. So let's look at an example and this is from the section on OMA in the draft. What I, and maybe also my co-authors, have felt that often it is easier to identify what are the initial beliefs, and then what happens after the protocol run is complete. Not always. So sometimes there are protocols that support both when there is some factory provision credentials, and some protocols that work in both scenarios, when the device is completely blank and when there is some credentials. So DPP would be one example which supports both. So you can have DPP running on a device that can support some kind of UI which is completely blank, but then if it's a thermostat which doesn't have any UI, then it can come provisioned with some keys. So there's always this challenge that protocols have variants, and trying to cover all the different variations becomes challenging. But still, from a beliefs point of view, it is relatively easy to distinguish protocols that assume whether something is initially provisioned or not, and what happens when the protocol is finished. What becomes more complicated is the terminology, because let's say there is no golden standard and commonality on how these different standards use these terms. So currently in the draft, we list bootstrapping, provisioning, initialization, configuration, and registry. But this is basically a dumb grep of the standard for these terms. And then if the standard has used that term, then it's in this list. I'm not sure if this is the best approach. So I noticed that the standard also, or actually Jaime pointed out that the standard also uses the term discovery. So we will add it to the list. But I'm not sure if just doing a grep of the standard document for these terms, and if they exist, just listing them makes sense, because in this case of OMA, there was like just one reference to initialization, which was basically like making the device kind of blank, or zeroing would also be an alternative term for this. I felt that maybe it would be better to just focus on the real terminology that is used for setting up the device. So in this case of OMA, OMA uses the term bootstrapping. Then you discover what objects can be provisioned, and you write to those objects, or you provision to those objects. So it's a question for the research group whether it would make sense to not just blindly grep the standards for this terminology and only list the ones where they actually make sense. So in that case, we would remove initialization from OMA as an example. Also, yeah, please, Carsten, I think you can already go ahead.
Yeah, so what I would want from this document, of course, is not just saying whether these terms are used, but in particular with which meaning they are being used. So we may need to define our own terms, or at least a reference framework, so we can say how things like provisioning, initialization, and so on are being used. And the problem, of course, is that terms like initialization also have a general computer science or even English sense, and it's sometimes necessary to find out which of the meanings is actually used. So same thing for configuration, for instance, while provisioning is often a very specific item that where we can find out how the document is using that. So this would be a little bit of a dictionary style thing that we would be doing here.
Okay, so I understand that for each of these standards, we should list the terms, and then in what context, or what is the meaning, what are they trying to imply with the usage of that terminology. Sure, I think it would just make it a little bit longer, but hopefully more useful document. I think that makes sense. The same, let's say, challenge I noticed was with the processes section. So I mean, there is obviously some benefit of explaining how each protocol works, and is that what we want from the processes, or should we only focus on what are the processes expected from, let's say, an end user or a network administrator? Does the protocol require you to, have some server running in the cloud from a service provider, um, or do you think it would actually make sense to have like a detailed explanation of how each um, protocol actually works? So how does OMA work? In my opinion, is less useful. I would rather find it more useful to explain what is expected from the user. And there again, it's not clear in the standard what is expected from the user, but I guess or the owner, I would think it's more like they need to configure the location of their lightweight M2M server on the Bootstrap server, and maybe at the end of the process verify that their device actually shows up on the server. But these are not then explicitly listed in the standard as processes. And finally, then these players, I think again this was a little bit let's say confusion added by the authors. Who are the players? I would say like uh, like a client or a device or a server is not necessarily a player. I would think that it would be easier to distinguish protocols based on whether they require some involvement from the manufacturer or not, and whether they require like some kind of a server or a service provider running a server, or the user running a server, but certainly not listing like every every player mentioned in the standard. So we would try to trim down the list unless the research group thinks otherwise. Um, so if there is some feedback, yeah, please, Carsten.
Yeah, I think processes, players, and beliefs are really the triangle that needs to be discussed together. So the point about a player is, well, there's another word that we are often using, which is party, which is related to player, but a party may be actually comprised of multiple players which have different states they are going through while together being that party. So who controls something is one aspect of party, but also the collected knowledge of the players in the party. And I think the interesting thing here about the players is not so much what are the detailed processes and how does the document with a relatively complicated set of players actually define the individual processes, but the point is that before something the device or the application can do something useful, certain beliefs need to be created, instilled, and these beliefs are in specific players. So it's not useful to have a belief that is freestanding. The specific device must know the key, or the manufacturer must provide the key, or and so on. So I think that's where the terms players and processes and beliefs are really interesting.
Should we have like then also parties as a group of players?
Yes, we could. I'm not sure how useful this is. In the end, a specific protocol really runs between players, but it's of course the sense, the reason this protocol, this process is there, is to get each party the assurances that the party needs. So the party always is the interesting thing in the background. But the other interesting thing about a security protocol is that a specific player may not necessarily properly represent its party. So if you have a rogue player, a player that goes rogue, that is going to compromise the security objectives of the party. So the party has security objectives, and the party controls certain devices, certain players, which hopefully are working together to realize those security objectives.
So in case of OMA, what would be, like, at least I listed these as the players, but maybe I don't know, we probably are running out of time, so we can also continue the discussion on the mailing list, but I think having like example for one specific protocol would then help make it easier for other protocols.
Yeah, I think it's a good idea to do this for OMA because it's sufficiently complex that the interesting questions will come up, and it's relatively stable and people understand it. So I think that would be a good exercise, and maybe we should actually find an hour somewhere where we do that.
Okay. I won't take much more time. So, well, I think this research group has experts on different protocols that we are trying to cover. So if you want to help us identify these players, processes, parties, beliefs for any of them, we look forward to comments, whether it's on the mailing list or pull requests. I mean, we understand that there is work to be done for the draft, so hopefully we'll have a major revision before the next meeting. Yeah, that's it.
Okay. So if there are no other questions, how do I share the next slides? This is weird.
Okay.
So you should have control now.
I have control now. Okay, so not even briefer history of this draft. Last time I had a longer history. We did this in 2020. It was found a location. It was adopted by this research group in January. Next steps are a bit unclear, and then profit. Non-goals of this draft are not trying to establish a new evaluation criteria, but rather to just provide terminology for what things you might want to talk about and what you might want to evaluate and what those numbers might describe without actually saying what the best number is. So that's up to you to do your own risk assessment or whatever. And part of this is to make it clear is that if someone is happy with the Cheetos keeping their storage unit closed because that's all the security they require, then they should be able to express that fact that that's the level of security they have, and that's okay. But on the other hand, if you want something stronger, then you should be able to express that, and we should be able to talk about it in a reasonable words as to what it is that you're actually doing. So some changes, some interesting things that have come forward. There is a requirement from last year from the Certification Authority and Browser Forum, known as the CAB Forum, not always with the slash in it. And they basically are a group that allows the CAs and the browsers to decide basically what trust anchors wind up in your browser and therefore which certification authorities can do what. So they've decided that, I think in as a result of the I forgot the company's name now. They're near me even. Their big thing where they had Trojans being shipped out to the field that were built on their build servers. That from now on, code signing keys should be not kept in, online, or should be in an HSM. And so the idea is that in order for the CAs to be sure of this, they need some kind of remote attestation from the HSM as to the key's provenance. It has to go into the CSR, and this is happening in the LAMPS working group right now about what exactly will happen. And there's a June 1st deadline for some of this. What is the overall effect of this is that we had in this document a bunch of questions as to, for instance, how is the key generated with, a couple of internal, views. So that's kind of, now I'm going to expand it out into some of the terminology that the design team in LAMPS has discussed, and they're going to figure out how to encode this into an attestation. But I think that these are probably pretty good set of terminology. And what's also interesting is that it's also come up with, there's also a second set of terminology as, for instance, whether or not the key can be extracted out of the device by the user, or it's extractable in an encrypted form that you can restore to the device later on, or can be extracted and restored into a similar HSM, but not by the user. And there's a bunch of different possibilities. So that's something that I'm going to expand in this document, try to get that terminology correct and get some review from some other people there. The next steps is more bike shedding. It's not a taxonomy document, I think, unless we actually do argue about the terms. So it's appropriate. And I think we should finish and get into whatever the last call process in the research group is sometime in September, and be done by the end of the year. That's about it. Go ahead, just speak up.
Yes, Michael, I am confused because the document talks about these keys, private keys, trust anchors for devices. But then there is also in your presentation mention about this CA forum. So
let me explain. Let me explain then, Mohit. So if you're going to put a public key into a device, such as, for instance, is going to decide what software can be applied to that device, or what kind of things, then somewhere you need to keep the private key part of that somewhere safe, right?
Yes, I'm very much involved in this process, so I can at least tell from one example where we keep the private key in a cloud HSM and then public key in a read-only file system to verify the software.
Right. So if you're going to put a trust anchor into the device, then you have to also know something about how does the management of the private key work out. So that's why that's the relationship. And the useful thing is the set of terminology that that attestation has to go with. So let's have some common terminology between this and the other areas where the terminology is being used.
But I think in the devices, the keys are generally burnt into like fuses. There's like how I don't know. Maybe
that is one method. That's one method of about 6. So you just described.
Which section of the draft should I look at for?
Well, that would be a device-generated key. Now, if you generate it in the device and store it in a puff, based on the puff, that may actually be a symmetric key based thing. Depends on how you're using you said puff. So that typically means that you have some symmetric key that comes out of the air. But that means that the key is generated in the device.
Okay, I think I was talking about something else, but at least I see in the draft there is this software update trust anchor. So what I was
look for device generated keys. That's, I think, section.
No, but like what I
2.
am doing, the key is not generated on the device. Only the public part of the key is burnt into the device to verify the software update when it comes.
That's fine. Then you have a trust anchor. So that's a different section, right? But then you have the generation of the keys. So that would be sorry, that is 4.1.2 section. So that's about key generation process. So that's one of the things that we want to have. It's a taxonomy of the key. So if you're going to generate the IDEV ID, you need the corresponding private key. Where do you put that? How do you generate it? Was it generated in the factory, or was it generated on the device, or was it generated for symmetric key? And then you can have the question is, can I extract that and restore it to a new device? That's the new part.
I think I'll send some comments on the list. But
all right, that would be great. Yeah. Thank you. I'm done. Carsten?
Yes, so thank you for this presentation and for giving us a timeline. I think this is a useful document because it gets some communication going there that wouldn't happen otherwise. So I think this is a valuable result. And yeah, we need to look at the definitions of the terms and find out whether they are useful in our respective corners of the world and comment to that. So I think we're done with that item. And the final technical item on the agenda is the discovery security. So people have been pointing to various terms that are not very well defined: discovery access control, secure discovery, privacy preserving discovery, and so on. And I think it would be a good idea for us to actually look at specifically discovery security and those other aspects on the title slide. Because discovery is important for IoT. We want to automate our setup processes as much as possible, both because of limited user interfaces in the devices and because we have so many of these devices that we can't attend to each of one like to a pet. And we also have different kinds of discovery, and I listed two here. One is network discovery and the other one is resource discovery. And they come together in various models or are separate in other models. And of course, how this is structured influences what we can do on the security side. So the first interesting question is, what are our objectives here? So the objective of discovery is, of course, that players can find other players, and that they can start building systems, understanding what those other players are. And so you have to find things or services, and you have to learn enough of them to do something useful once you have found them. And the objective, of course, includes security objectives and using the usual CIA grouping of security objectives. We have confidentiality, which is an adversary cannot learn things it shouldn't learn. Integrity, an adversary cannot inject information or spoof information that could be used to violate other security objectives. And finally, availability, so there is no way for an adversary to disrupt functioning. And we can look into a little bit more detail here. So why do we need confidentiality? well, first of all, we have privacy requirements, so that there are lots of examples where people point out that finding out what devices are somewhere already violates privacy. So if I'm doing a job interview and I have a way to find out whether there is an insulin pump in the room, I might be able to find something about some health information about the applicant that I'm not entitled to receive. Or some thugs could work around neighborhood and scan for expensive gadgets using discovery mechanisms to find a house that is worth to break in and steal things from. So the privacy requirements may be somewhat surprising. They do not necessarily come directly from the function of the devices. And even the simple use of stable identifiers creates linkability issues, which is being worked on. And we have a whole working group, Madinas, to actually handle the fallout of this upgrade. So that's one aspect, privacy. And of course, privacy is not just personal privacy, it's also privacy of business information that has similar properties. But also we want to avoid disclosing things that would increase the attack surface, like the exact version of software that runs on a device should not necessarily be available to everyone. It should certainly be available to the manager of the network, but not necessarily to somebody who randomly is in the vicinity. So in the past, in the past, we have often just fallen back to network security or subnetwork security, just assuming that our discovery is secure because we can confine it into this space, and that of course becomes difficult in an IP environment. For resource discovery, and we talked about resource directory just a few minutes ago, it's pretty clear that we want to have a view approach, so authorized users see more information. But of course, that means that you have to classify the information into these different classes and specify authorization for the information. And to have authorization, you need authentication. And how does the authentication work in a state where you are still discovering who the other guy is? So that's interesting. And very similar considerations come up with integrity. So integrity is of course always very important, but here in this context, the attack would be to inject or spoof information that either DOSs the discovery or confuses players enough that they think they have a valid peer to talk to. And again, we have been using subnetwork security, and again, we have this authentication authorization issue. How do you operate with partial information? Because you are still discovering whether you actually want to talk to that other guy. So why should you give up all your authentication information in this process? And finally, availability. The completeness of discovery is something that an attacker might try to work again, in particular if that is using multicast. But you could also try to abuse discovery capability for DOS. So again, resource use should require authorization, and we run into the same questions. Who is authorized to do something, and how did the authentication that is underlying that authorization actually work? So in summary, there is a strong reason to view discovery security, among other things, as an authorization problem. And we should be more specific in what authentication methods and authorization models can be used in a discovery phase, I think we have a pretty good understanding how to do this with the resource directory, but there are lots of other places where this comes up. And in particular, when you are still in the process of choosing the right network, the Christmas problem, everybody unpacks their IoT gadgets they got for Christmas, and of course they all log into the neighbor's network and do weird things there. So that's one aspect, and that requires thinking about partial authentication, partial authorization. And one thing that we have already discussed in Wishy in 2017 is that it would be nice to have secret handshakes, which are mutual authentication procedures that actually complete before anything is disclosed to a non-authorized party, and that seems to be a critical building block to get secure discovery going. So the point of this talk was to raise questions, and what I would like to find out is, are these interesting problems, are these important problems we should be solving, or we should try to get researchers to solve, or we should simply try to document the state of the art and potential gaps. And if we think so, who would be interested in doing something about this? Should we try to write some of this up? And yeah, if yes, maybe we should allocate time for a meeting of interested people. So we have a couple more minutes to get input from the group about my questions. Okay, so nobody cares about discovery? Jöran.
Yeah, yeah. This is interesting, but some of the questions was a bit. I mean, this secret authentication was a bit like, if you don't know who you authenticate to, why does it matter? Except if you want to conceal to others, of course. But I have a question. First question is, we have the resource discovery, the core resource discovery RFC, and I suppose some of these things are considered in that when it comes to discovery. How does this position itself to that? I mean, of course, it's not specifically for the resource directory, but isn't it the same type of security problems that should have been answered in that RFC?
Yeah, I think we can learn something from how this has been done in the resource directory. But the resource directory also has the advantage that by the time you are using it, you are already authenticated to the network, and you might be in a position to authenticate to the resource directory. So it's already an advanced phase of discovery. So the approaches in that document do not necessarily transfer to early discovery. And early discovery, the part that would actually benefit from a secret handshake, that definitely cannot expect that authentication already has been done at the time when it is decided whether to disclose some information or not.
So you're saying that you have network, you have authenticated to the network before you do resource discovery, but you have not authenticated to the discovery mechanism. So what is the difference?
Well, if you don't have a way to authenticate to the resource directory, it is going to give you only limited information. And that is an authorization model that I think is reasonably well understood. Less well understood is whether that information is enough to actually get you going into a state where you actually can authenticate to the resource directory.
Okay, thank you.
Michael.
So this is all very interesting, and I would love to have more conversations about it, but I don't know what we do with it. And I guess I'll say that, like I don't know in the end, I don't know what the body of work that you're proposing to do is, if it's more than just talking about naming and discussing or writing down the attacks. But I guess I'll say that Christian Wiedema tried to do the secret handshake. You know, I can't tell you whether I exist until I know whether or not you're supposed to exist. In DNSSD, what it was about 8 years ago, maybe 2015 or something. I think it was, and I was sad that the work didn't go anywhere. Partly because I don't think anyone was quite ready for the concept. We just don't have broadly interoperable IoT networks yet, such that I really could wander down the street and learn whether or not there are insulin pumps to steal or not. It's just not interoperable enough at this point. That's our current security level of security. It doesn't work, right? So I think it's really important that we get here, but I don't know if the world's ready for this yet.
Yes, I mean that's why this is good stuff for a research group and not for trying to standardize anything. But what you describe is pretty much the main reason why it's so hard to do security, because the best way to avoid a security problem is to make the systems not work. If they don't work, you don't have a security problem. And our interest, of course, should be to find ways to make things work. But if we run into problems like this one, as soon as we make things work, that will make it hard to make things work. So I think it's good to think about them a little bit ahead of the curve. Milan. We can't hear you.
Can you hear me now?
Yes.
I have unmuted, I think. Anyway, so my answer to the question, is this interesting? Yes, it is. And it would help, I think, even before you write up, or as you are writing up, to identify a bit of the scope. Basically, who can discover subject, to security constraints, and which constraints do you want to put in place, and how much can be discovered. That, I guess, also would be graduated based on the level of trust between the two parties. But the related question, a similar problem exists in the Bluetooth networks, and somehow it seems to work with the discovery and pairing, if so desired. How would this be different in terms of what it does and how it operates?
One interesting thing about Bluetooth networks is that the various products that are out there usually need a manual step to actually set up some initial security. And the cases where that is not the case, discovery is really awful. So I have to be really careful in my apartment not to send music to the TV of the guy living upstairs to me. It's really hard to avoid because my systems discover that thing and start sending audio to it. Yeah. So I hope that's not the Bluetooth mechanism you were referring to.
Well, I don't know. I was referring to Bluetooth of connecting my own devices to stuff that works, yes, and I can see some neighbors' devices which can be used for entertainment if you want to blast some annoying music to them. But in general, it seems to work, obviously, the devices that are in proximity of each other, which may or may not, it depends on how you define it, the case for what you are doing. But it definitely works for my stuff. I just haven't paid attention how much it extends beyond that and exposes other devices and my devices to other parties. That I haven't researched in detail, so I cannot, I don't have a feel for it.
Yeah, so if we find that Bluetooth has solved this problem for us, then we should write this up and explain how to transfer this knowledge to our place. But I think the manual step is a significant difference between how I think discovery should work in the IoT space. So I think that is at least one aspect that is going to be different.
Yeah, you're right. It requires user interaction with at least one of the systems.
Yep.
Yes.
Okay, thank you, Marco.
Yes, hi. I think it's an interesting topic, and I confess I'm biased by the model considered in the resource directory. I tend to forget about any early discovery issues. But like Milan said, I think we should first understand the scope better, and maybe a first starting point can be defining a taxonomy of trust models for the early discovery phase. And like kickstarting that can be a topic for a follow-up meeting, for example.
Sounds good.
Yeah, thanks.
Do you have any document or source you would point to on this?
Actually, no, there'll be an opportunity for me to understand even better some of the building blocks
Okay.
you mentioned in the previous slides.
Okay, so let's take that to the list.
But if I'll find any, I'll tell you, of course.
Great, thank you.
Thanks.
Yeah, we are 6 minutes over time. So I think we are done with the queue, and I think that's very good feedback that we have to think about scope. I deliberately presented this as a very wide open thing, but of course we have to focus. And I think that's one of the things we should do in that list discussion and maybe first meeting. So thank you for your input. And I think we are pretty much done with the agenda. Let's go to the agenda. Yeah, we are done. So I expect we will have further point meetings, work meetings in the next few months, maybe at the cadence of about one per month. So if you are interested in having a meeting like today on a specific topic or a set of topics, please talk to the chairs. And apart from that, thank you for joining this meeting, and see you on Meet Echo or physically at an IETF later this year.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.